Good evening. Can all of you hear me loud and clear? Hi, I see Adam here, Nafisa, Adam Haris, Irfan, Danish, Huda is here, Ifa, uh, Daniel Khan is here. Who else is here today? So I'm expecting about 40, 45 or 46 of you. So right now we only have 22. So I'll give your friends about a couple of minutes before we start today's session. Okay, so how's everyone? How's your day today? Are you excited about tomorrow? Speed is a weaker subject. Yes, it's a weakest topic for many students. That's why I want to conduct this webinar to show you 8 different kinds of speed questions, which I believe if you are able and master, you'll be able to do majority or most of the speed questions. Okay, Adam is nervous about tomorrow. Hi, Rehan, how are you? Were you here yesterday, Rehan? I didn't remember seeing you online yesterday. Okay, we have Irfan Yusri here. Okay, who else is here? All right, so those of you who are here, I want you, okay, Farah is here. I want you to take out, make sure that you have a piece of paper with you, your calculators, and a pen or pencil. All right, a piece of paper, your calculator, or a pen or a pencil. Okay, so because you need to do some workings today. All right, all of you, if you don't have a piece of paper and a pen and calculators, can you please fetch them now? Okay, while we give your friends who are still coming in a few more minutes before we start. Okay, Softly is here. How are you, Softly? Ready for tomorrow? All right, Safia is here. Faris, no Faris, Farah. Done. Okay, very good. All of you have your calculators with you, huh? Okay, so in this session, it's going to be quite intensive. It's going to be quite intensive. Why? Because you will need, I'll give you some time to work out the answers to the questions, okay, before I explain. Okay, so you must do quite fast because I'm not going to give you much time. Okay, because we don't have much time because I'm going to cover 8 different types of speed questions. Okay, right now we end at 9:30, but at 9 o'clock I'll give you, we try to end by 9 o'clock. If we have the time, I will open to everyone. If you have any questions, you can ask questions. Okay, is everyone ready? All right, let's start. Let's start. All of you can hear me, right? Okay. So in this lesson, okay, I've been thinking what are the topics that the students, all of you will need most. And there are many topics. I know some of you have problems in different topics, fractions, percentage, right? But I choose to do speed for this webinar. Speed is a relatively new topic where you all learn in primary 6 and some of you are not very firm still with the different kinds of speed questions. Okay, so if you are not able to catch in today's session, no problem. I'm recording this session. Later on, by today or tomorrow, I will upload onto YouTube and I will share the link with your parents so that you can review today's lesson. Okay, Hannah, how are you? Good. All right, Irene, loud and clear. Very good. So those of you who just came in, please take out a piece of paper, okay, as well as a calculator and a pen or a pencil. Okay. All right, everybody. Okay, so a bit of house rules again before we start today's session. Once I start, please refrain from chatting with one another. Okay, so those of you who are caught chatting or chatting nonsense stuff, especially, okay, I will ensure the next webinar session we will not let you participate, right? Because everybody wants to learn as much as possible this session. Okay. And if you have any questions later on, please you can write down on a piece of paper, and then you can ask me at the end of the session. All right. So I will try to end by 9 o'clock, and I'll give you about half an hour for Q&A at the end of the session. If you still don't understand, okay, if you are not able to catch, you can always ask me during our session in the class. Okay. All right, those of you who cannot hear me, there's nothing I can do because most of the students have no problems at their side. I believe you have to adjust your own system, perhaps your speakers. If it is lagging, you must check your Wi-Fi. Okay, maybe you are too far away from your Wi-Fi or Wi-Fi too slow. All right, so this system, there's no problem at all at my side, and most students don't have any problem. So if you are not able to hear or see or lagging, you have to adjust on your own at your side. All right. Okay, so if okay, if it's lagging, okay, there's nothing. I repeat, there's nothing I can do at my side. Okay, what I can do is that we are recording, and later on when I upload, and then you can see that there are no problems with the session itself. Okay, so try as much as possible to follow. But if you can't, no problems. Once I will share the link with your parents so that you can review the session. Okay, everyone. All right, let's start. I shall not waste time. Okay, so today I'm going to cover 8 types of speed questions. Okay, 8 types of speed questions. And if you're able to master these 8 types of speed question, I believe you can do all or most of the speed questions in the PSLE. All right, so number one, we are going to learn about speed questions, journey by parts, average speed. Number three, same direction, start at the same time, meaning two vehicle or two objects moving in the same direction, starting at the same time. The fourth type of speed question would be same direction but start at different time. Okay, for example, Ali and Ben were running. Okay, Ali runs first ahead, and then Ali starts say 10 minutes later. All right, and when Ali is faster than when Ben is faster than Ali, so there will be closing of the gap. Okay, so that's one type of question. The fifth type of question is that same direction, start at different time, but opening the gap. Okay, so meaning that the first student runs, okay, or the first vehicle moves, and then the second vehicle or object move later on, but because the second object is slower than the first object, the gap becomes bigger. The gaps become bigger and bigger. Okay, and six is moving towards each other from opposite direction, starting at the same time. So you have two objects. All right, you have two objects moving from opposite direction, and they start at the same time. Okay, so maybe you have a car and a bicycle moving from opposite direction, but they start at the same time. Okay, towards one another. All right, the seventh type of speed question is that they are moving towards each other, but from opposite direction. Okay, starting at different time. Okay, so A moves first and then followed by B. Okay, they start at different time, all right, but they are moving towards each other and they will meet each other or pass by each other. Okay, the eighth type of question is that moving away from each other. Okay, that means they are moving two objects. Okay, they are moving starting from the same, moving away from each other. Okay, away from each other. So we have different types of speed question that they can ask you in the exam. Okay, everyone. All right. Now, I repeat, I see some of you are chatting one another. Please refrain from chatting. I want all of you to focus. Okay. All right. Let's take a look at the first question. Okay. So I give all of you 3 minutes to look at the question and try the question on your own. Okay. Please do now using a piece of paper. All right, see who can get the answer first. Anyone can get the answer? 350 kilometers. Anybody else wants to try? Both A and B. Okay, A 350, right? Rest of you, I give it more time to work out. What about B? Please work out B also. I say 200. Aris, you sure? 350. Ifa, 350. What about part B? 210. Anyone else? Rest of you, I hope all of you trying. Okay, let's start with this question. A motorist traveled 2/5, okay, of his journey at 80 kilometers per hour, after which he decreased his speed to 60 kilometers per hour and completed the rest of his journey in 3.5 hours. So you can see that there are two parts of the journey. The first part, which is 2/5 of the 5 minutes. His speed was 8 kilometers an hour, and then after that, the second part of the journey, he decreased his speed to 60 kilometers per hour, and he took 3.5 hours. Now remember, the most important formula for speed, or the only formula that you need to know, is distance DST, right? DST. Okay, distance, speed, and time. Now let's recap a little bit. If you want to calculate distance, the formula is speed multiplied by time. If you want to calculate speed, distance divided by time. And if you want to calculate time, distance divided by speed. Okay, so the very first thing that you need to do if you see such speed question, you need to draw the distance speed timeline. Okay, the timeline, so that you can visualize the problem better. And I see many students here, after even repeating many times, many students still refuse to draw the distance speed timeline. Okay, now if the question is easy, okay, perhaps you can do mentally, but if most of the questions, speed question in the PSLE, you can see it is 3, 4, or 5 mark questions, right? They are challenging questions. If you do not draw the distance speed timeline, very difficult for you to visualize and get the answer. Okay, now let's start. So you can see the first part, right? 2 out of 5. So the first part of the journey is 2 units, and the speed is 80 kilometers an hour. So I write down the speed 80 kilometers an hour. Now the second part is 3 units, right? How do I get 3 units? 5 minus 2, right? The total distance is 5 units, and here you have out of 5, 2 units in the beginning and 3 units the second part of the journey. So once you're given the speed and the time, right, straight away, don't waste time. Remember the formula, DST, right? DST, if they give you, in the question, they give you speed, they give you time, right? Straight away, you can find the distance, right? So distance is speed times time. Okay, so in the second part of the journey, speed times time, 60 kilometers per hour, multiply 3.5 hours to get 210 kilometers. Please ensure that your units are correct. Right, if it is 60 kilometers per hour, and this is in hours, right, you must ensure that the units are consistent. Kilometers per hour, the time here must be in hours. If they give you in minutes, so you ensure that you convert the time from hours, from minutes to hours. So this is a very common mistake. And the answer here, you get 210. Okay, so 210 is the second part of the journey, but the question asks what was the total distance, okay, that he traveled. So 3 units is 310, 1 unit is 70, 210 divided by 3, you get 70. So 5 units is 70 multiplied by 5, you get 350. Okay, so those of you who get the answer 350, very good, well done. Okay, you got it correct. Now part B, given that the motorist reached the destination at 1:30, at what time did he start his journey? Now your answer must be before 1:30, right? Why? The reason being that he reached the destination at 1:30. So how long did he take, okay, to cover the entire distance? Okay, so in the first part of the journey, you know that units is 140 kilometers. Okay, 140 kilometers, that's the distance he traveled in the first part of the journey. So the time taken, time is distance divided by speed. So you know the distance which is 140 in the first part of the journey, and the speed was given at 80 kilometers per hour. Okay, so the time is 1.75 hours. Okay, or 1 hour, 1.75 hours. Okay, and you convert, right? The total time taken for the journey 1.75. Okay, plus 3.5 hours. Right? Remember, this is 3.5 hours. The second part of the journey, it is 2.25 hours. Or if you convert to hours and minutes, it will be 5 hours 15 minutes. Okay, 5 hours 15 minutes. So backwards, 1:30 p.m. less 5 hours 15 minutes, you get 8:15 a.m. Okay, you got 8:15 a.m. So who got 8:15 a.m.? Very good. Okay, Farah, Adam, well done. Heng, very good. 8:55 is wrong. 8:15 a.m. 8:15 a.m. Okay, Ifa. All right, no problem. You get it wrong. Later on, you can redo the questions. Okay, anybody do not understand? Okay, Rehan. Okay, very good. You got calculation error, but now you understand. So a common mistake here is the conversion, right? Conversion between hours and minutes. So you must be proficient in converting from hours to minutes. Okay. So if you so there's a common error. Careless. Okay. So try and ensure that you reduce or you do not make any careless mistake. You must check. Okay. Nafisa. Okay. Well done. All right. Can I move on to the next question? Okay, let's move on to the next question. All right, so the next strategy or the next kind of speed question is average speed. All right, so I give you about 3 to 5 minutes. Okay, please work out this. Okay, remember, first thing you need to do is draw the distance speed timeline. Okay, always start your distance speed timeline so that you can visualize the problem better. Okay, the Adam got 2:04, 14:04, 14 p.m. Rehan 14:04. All right. Those of you who have done part A, try to move on to part B. Yeah. Anna 14:40. Check again. 14:04 p.m. Okay. Please take note. The time given here is in 24-hour format. All right. So must be in 24-hour format as well. So you don't need to put AM, PM. Okay, so 14:04. Okay, very good. 14:04. Not 14:40. Those of you get 14:40, please check. All right. Now let's solve this question together. At 11:50, Kiran started. 11:50 is the same as 11:50 a.m. But since this is a 24-hour clock, so 11:50 automatically means that it is a.m. Okay, so Kiran started cycling at 25 kilometers per hour from her home to a park, which is 10 kilometers away. So the distance from her home to the park, we know that it is 10 kilometers. She was at the park for 1 hour, 50 minutes. So perhaps she rested at the park for 1 hour and 50 minutes. And then she left, right? She left the park. After leaving the park, Kiran cycled back along the same route and took 40 minutes to reach home. What was the average speed in kilometers per hour for the journey home? Okay, now let's solve this problem. Let's draw first. Okay, so the distance from home to the park is 10 kilometers, right? So the distance is 10 kilometers. And we know the speed is 25 kilometers an hour. So if you know the distance, right? You know the distance, and you know the speed, straight away you need to calculate, right? So what is the time? Time taken will be 10 divided by 25, right? 10 kilometers divided by 25. So check whether the units are consistent. You get 0.4 hours. Now 0.4 hours is equivalent to 24 minutes. Now how do you get 24 minutes from 0.4? Very simple. 0.4 multiplied by 60. Okay, 0.4 times 60. Right, you get the answer in minutes. Okay, so Kiran traveled, took 24 minutes to travel from home to the park. Right, and please take note that she was at the park for 1 hour 50 minutes. I mean, she rested. So what time did she leave the park? Right, so she left the park 11:50 plus 24 minutes. Okay, and then add on 1 hour 50 minutes, you get 14:40. Okay, 14:04. Okay, 14:04. All right, understand everyone? Very good. 1 hour is 60 minutes. Please take note, not 1 hour 100 minutes. So that's why many students, they make this simple mistake. It seems simple, but it affect your entire problems. It may affect your entire answers. Okay. Now let's take a look at the second question, second part. After leaving the park, Kiran cycled back along the same route and he took 40 minutes to reach home. What was the average speed? Okay, now formula for speed is distance divided by time. Now what was the distance going back home? You know that when the distance from the home to the park is 10 kilometers, from the park back to home, obviously is the same 10 kilometers, right? And what's the time taken? The time she took 40 minutes. Okay, this one you need to be extremely careful because here it is the units given is minutes. So what do we need to do? What do we need to do if the units given is in minutes? We need to convert to hours, right? So 40 minutes is 40 over 60, right? 40 over 60. Okay, so after you convert, then you divide. All right, so let's take a look here. Speed is distance divided by time. So distance we know is 10 kilometers. The distance is 10 kilometers, so the time is 40 over 60. So when you divide 40 over 6 by 40 over 60, you get 15 kilometers per hour. Okay, all get correct? Anyone make careless mistake? Okay, everyone, all very good? Okay, well done. Ayuni, okay, very good. Are this all okay? Okay, let's move on to the next question. Well done, everyone. Okay, let's do this question. Okay, Sharon and Singy. Okay, this strategy, the third type of speed question, moving in the same direction, start at the same time. This is very common. Let's say you having a race, right? You run a race starting at the same time, same direction with your friend. Okay, so Sharon and Singy started cycling at the same time along a 4.5 kilometers track. Both did not change it from start to finish. Sharon cycled at 375 meters per minute. So you can see the speed here is in meters per minute. When she reached the end of the track, Singy was 600 meters behind her. What was Singy's cycling speed in meters per minute? Okay, so I give you 2 minutes to work out this question. Okay, all we got the answer? 50. You sure your answer, Yiheng? The answer is 50. 195. Okay, please remember the answer in meters per minute. Okay, it has to be in meters per minute. Take note. Okay, that's why you need to be extremely careful because the distance here is in kilometers and the speed here is in meters per minute. Okay, now let's do together. Some of you are already stuck. Okay, now let's draw the distance speed timeline. All right, so this is the start. So both of them start together. Okay, so they cycle along the same routes and the entire distance is 4.5 kilometers. All right, so both of them did not change speed, and Sharon cycled at the speed for Sharon is 375 meters per minute. When she reached the end, Singi was 600 meters behind her. Right, so this is Sharon and this is Singi. So 600 meters. Okay, so if this is 600 meters, this part here from start to where Singi is 3,900 meters. So you notice that I converted everything to meters. All right, why? Because the answers that they want in the end, the answer must be in meters per minute. All right, so easiest is for us to convert every meters. Okay, now let's start to calculate. First, we know that Sharon, the speed is 375 meters per minute, and we know that the distance of the race is 4,500 meters. Okay, so we know speed, we know distance, we calculate time, right? All right, so the time is 4,500 divided by 375, you get 12 minutes. Okay, so Sharon took 12 minutes to cycle from start to the end, right? At the end, she took 12 minutes. Okay, she took 12 minutes. Okay, next, then they ask you, right? What was Singi's cycling speed? Okay, so the distance from here to here, right? 600. If this is 600, this is 4,500. The distance traveled by or cycled by Singi is only 3,900 meters. Now, this part you must take note. When Sharon took 12 minutes to end the race, right? To end the race. Now, how long does Singi takes to reach this position? Anyone? How long does Singi take to reach this position? Farah? Okay, well done. Why 12 minutes? Irfan, why 12 minutes? Does all of you know it is 12 minutes? Yes, right? Because they say that when Sharon ends the race, right, finish the race in 12 minutes, Singi was behind by 600 meters. And so from the start to finish, from the start to this position, okay, Singi took 12 minutes, right? So in 12 minutes, Sharon ended the race, but Singi is only at this position, right? Because since both of them start at the same time, okay, so Singi took 12 minutes to travel from start to this position. And since the distance is 3,900, okay, so distance divided by time, you get 325 meters per minute. Okay, understand everyone? You know mistake. Okay, Nafisa, understand? All of you okay, huh? Simple enough, huh? All right. Well, very happy that some of you get the correct answer. Those who get the wrong answer, you understand your mistake. Okay? So the key strategy here is that you must understand that when Sharon ends the race, right? Sharon took 12 minutes. So Singi, which was behind, took also 12 minutes to reach from start to this point. So if you know this part, then easy for you to answer the. Okay. All right. Let's move on to the next question. Okay. So this time around, they move. Two objects move in the same direction, but start at a different time. Okay. They start different time. One start ahead. Okay. The other one start later. But then there was a closing of the gap. Okay. There was closing or overtaking. Okay. So I give you 3 minutes to work out. Okay, let's read together first. Now this is the concepts. Okay, the faster object, which starts later, right? Which starts later usually overtakes the slow object before they reach the destination. Okay, so you must take note here. Listen carefully. One object start first. In the second object, when the second object start later, it usually overtakes. Okay, or meet up with the first object before they reach the destination. Since they all started at different times, there will be a distance between them at the start. So at the start, there is already a gap. So it's a matter of closing the gap. So the gap from the start already there's a gap. So you want to close it. Okay. All right. So at 10:30 a.m., the cyclist started traveling on the road at an average speed of 30 kilometers an hour. At 2:30, right? 2:30. A few hours later, the motorist started from the same place, traveling at the same road. If the motorist took 4 hours to catch up with the cyclist, find the average speed. Okay? All right, so I give you about 3 minutes to work out this problem. Right? Okay, those of you who have not tried, please try. Okay, I shall not tell the answer. Let everyone have a chance to try. So those of you who are stuck, please draw your distance speed timeline so that you can visualize the problem. All right. Always draw the distance speed timeline so that you can visualize the problem. Ifa, give up. Try, try. Don't worry, I give you some time to try, Okay, let's give you all some clues, Let's give you all some clue. Okay, let's draw the distance timeline, Okay, so at 10:30 a.m., right, the cyclist started to move, right? The cyclist started first at 10:30 a.m. The speed was 30 kilometers per hour, right? So when the cyclist was somewhere in the middle, the motorist then start. At what time? It started at 2:30 p.m. So at 2:30 p.m., the cyclist will be ahead, right? Will be ahead, and the motorist was just starting at 2:30 a.m. So 10, 11, 12, 1, 2. So in 4 hours time, right? So there was a 4 hours gap between the cyclist and the motorist. Okay? So if the motorist took 4 hours to catch up with the cyclist, so catch up means what? Both of them at the same place, right? Both of them at the same place in 4 hours time. 4 hours time means what? 2:30 for the cyclist, 2:30 p.m. plus 4, you get 6:30 p.m. Right? 6:30 p.m. Both of them are at the same place. Right? So how long does the motorist take to close the gap to reach the cyclist? Okay, so this is a clue for you. Right? Very good. Cover the gap or close the gap. Does the motorist take? From 2:30 to 6:30 p.m. So you know he take 4 hours, right? He take 4 hours because at 6:30, right, the cyclist and the motorist they meet up. Why? How do you know? Because the clue given to you that if the motorist took 4 hours to catch up, so the cyclist at 2:30, right, you plus 4 p.m., right? So the cyclist and the motorist were able to be together, right? And the motorist, remember, the motorist started at 2:30 p.m. So at 6:30, the motorist took 4 hours, right, to close the gap. Okay, so the question is, find the average speed of the motorist, right? Average speed is distance divided by time. Now, what is the distance and what is the time? Right? So, when the motorist catches up, the cyclist had traveled for 8 hours, right? The cyclist traveled 8 hours. How do you know 8 hours? So from 10 a.m. to 6:30 p.m. So the total time taken is 8 hours. And given to you in this question, the speed of the cyclist is 30 kilometers an hour. So you know time and you know speed, you can find the distance of the cyclist, right? So distance is speed times time. Speed 30 multiplied by 8, 240 kilometers. So you know from the start to where they meet, the distance is 240 kilometers. But the question asks, what was the speed of the motorist? Right? Speed is distance divided by time. Right? Since we know that the distance is 240 kilometers, right? Because from the beginning until the time where they met, the distance must be the same. But the motorist took only 4 hours. So 240 divided by 4 hours, you get 60 kilometers per hour. Okay? If I understand? Very good. At least all of you understand. Okay, well done, everyone. Rest of you, are you all following? If you cannot follow, please let me know. I only see the same person here. Understand? Okay, very good. Okay, let's move on to the next question. All right. Strategy number 5. Opening the gap. The difference just now was closing the gap, right? But this time now is opening the gap. Right? Same direction, both start different time. One start earlier, but this time around, the second object that moved did not manage to overtake. Why? Because the first object moved at a faster speed compared to the second object. Okay, so there was an opening of the gap. The gap becomes longer. Okay, so this question tests students on scenario whereby two objects start from the same location and one will be further away from another. Okay, let's take a look at this question. Let me read for you. Right, then later on I'll give you some time to try. Okay. All right, John started cycling from point A to B at 7 a.m. Okay, at an average speed of 12 kilometers per hour. David started cycling from A to point B 3 hours later. And John's speed is twice of David. So we know that since the speed is twice, we know that David will never be able to catch up, right? So at what time were the two cyclists 48 kilometers apart? All right. Okay. So I give you some time to try. All right. I give all of you some time to try. Please try. Okay, some of you get 2 p.m., some 12 p.m., 12 p.m. All right. Okay, so it seems that all of you get 12 p.m. Okay, let's discuss the answers. Okay, as usual, let's draw the timeline. So you can see at 7 a.m., John, traveling at speed of 12 kilometers per hour, started cycling. All right. So John cycle, right, at this point. And when John is somewhere in the race, David started, right, 9 a.m. So David cycled at half the speed, which is 6 kilometers per hour. Okay. So when John reached the finishing point, right? When John reached the finishing point, David were at this point, right? David were at this point, and the distance is 48 kilometers. Okay. Now, distance by John after 3 hours, right? So since distance is speed times time, right? Okay. So the speed is 12 kilometers per hour. The time taken is 3 hours. Okay. So we know that John traveled the distance of 36 kilometers. So there was an increase in the gap. Okay, 48 kilometers minus 36 kilometers. Okay, which is 12 kilometers. So for every 1 hour, okay, John is ahead by 6 kilometers. For every 1 hour, John is ahead by 6 kilometers. Now, since Okay, since it is ahead by, it is 3 hours later. Okay, so for 12 kilometers divided by 6 kilometers, you get 2 hours, right? So 10 a.m. plus 2 hours, you get 12 p.m. Okay, so most of you got it correct. Huh? Okay, so at what time were the two cyclists 48 kilometers apart? Okay, 2 hours later, which is 10 a.m. plus 2 hours, okay, which is 12 p.m. All right. Okay, well done. Okay, let's move on to the next question. Huh? All right, so the next strategy is moving towards each other from opposite direction, start at the same time. Okay, so what does this mean? Say they're moving towards one another from the opposite direction, but they start at the same time, right? So it's very common for the race, right? First, go to together, right? Starting at the same time. So at one point they will meet up, right? Because they are coming from opposite direction. The time when they meet is the distance between their starting points divided by the sum of the speed. Okay, so let's take a look at this question. The car left town A at 8 a.m. and traveled to town B at an average speed of 3 kilometers per hour. At the same time, a lorry left town B. Okay, so town A, and then the lorry left town B. All right, so what is this direction? The other one is this direction. At 10:30 a.m., the car and the lorry were 85 kilometers apart after passing each other. Okay, the car and the lorry is, so the car will be here and the lorry will be here, right? And it will be 85 kilometers apart. If the car arrived at town B at 1 p.m., at what time would the lorry arrive in town A? Okay? So I'll give you some time to work out. Huh? Okay, please work out this problem. Okay, I'll give you all some clues. Huh? Okay, I'll give you some clue. Okay, so you can see here, the car left town A at 8 a.m. Okay, at the speed of 60 kilometers per hour. Okay, and the lorry moved from B, okay, for town A at 8 a.m. as well. So at 11:30, right, both of them pass each other, right? Both of them pass each other, and they were 85 kilometers away, apart from each other, right? So at this point, it is 11:30 a.m. The car at this point is at 11:30 a.m. The car is here, and the lorry is here. Okay, so this is a clue for you. Huh? Okay, please look up. See who can get the correct answer. Okay. Okay, we know that. I give you all the clue, further clue. Right, when the car arrived at town B at 1 p.m. So how long was the journey for the car? From 8 a.m. all the way to 1 p.m., right? So how many hours is that? 8, 9, 10, 11, 12, 1, 5 hours, right? So the car took 5 hours to travel from town A to town B. Okay, the car, and then the speed is given, right? The speed is given at 60 kilometers an hour. So once you are given the time and you are given the speed, you can find the distance, right? So the distance will be speed times time. Okay, 60 kilometers per hour. The speed is given here. The speed is given is 60 kilometers per hour, right? The speed for the car. Okay, so you know the speed is 60 kilometers per hour. The time is 5. Paris try, right? So you know the speed of the car is 60 kilometers per hour. So the car started from town A at 8 a.m. and then reached town B at 1 p.m. Okay, so there's a total of 5 hours, right? 8, 9, 10, 11, 9, 10, 11, 12, 1. 5 hours. So 60 times 5, you get 300, right? So the distance is 300. Distance between town A and town B is 300. Okay, Irfan, which part you don't understand? Ifa, you understand? Okay, some of you 1 p.m. You are stumped. Okay, never mind. Some of you are stuck. Okay, let me explain. Okay, the answer is 2 p.m. Anybody got 2 p.m.? Yiheng, well done. Very good. Yiheng got 2 p.m. Who else get 2 p.m.? Rehan, okay, well done. Very good. Okay, now let's do together. Let me explain. Okay, so DT, what does DT stands for? DT stands for the distance by the car. Sorry, not DT. This one should supposed to be by the car, DC. Yeah, we know that the speed. Okay, the speed of the car is 60 kilometers per hour, right? 60 kilometers per hour multiplied by 5, right? You get 300 kilometers. Okay, so the distance between A to B is 300 kilometers. Okay, and 60 multiplied by 1.5. Okay, you get 90 kilometers. Now, do you know how I get 1.5? 1.5 is, how do you get 1.5? That means from here, the car to travel to, right, to reach town B, it takes 1.5 hours, right? So remember the car, at this point, the car is already at 11:30 a.m. So to reach town B, the car took 1.5 hours. So 60 times 1.5, 90 kilometers. Okay, so this is 90 kilometers. So 90 kilometers plus 85 kilometers. So you get 175 kilometers. So 175 kilometers is from here to, okay. Now what about speed of the lorry? Now speed is distance divided by time, right? So the lorry travel from here to here. The distance is 175. And the time taken is from 9 to 11:30 a.m., right, is 3.5 hours. So 175 kilometers divided by 3.5, right, you get 50 kilometers per hour. This is the speed of the lorry. Okay, so the speed of the lorry, we know that is 50 kilometers per hour. And at what time did the lorry arrive at town A? So the time by the lorry, time is distance divided by speed, right? So we know the speed is 50 kilometers per hour, and we know the distance is 300 kilometers. So 300 divided by 50 kilometers an hour is 6 hours. Okay, so total time taken by the lorry is 6 hours. Right, so since 8 a.m., okay, and after 6 hours, it will be 2 p.m. Okay, everyone? So you can see it's not so straightforward. So if I ask why 1.5, anybody can answer if 1.5. Where we get 1.5 here? Okay, very good, Daniel. From 11:30 a.m. here, because remember the car traveled from town A to here is 11:30 a.m., right? From this point to the ending part, which is town B, the town B she reached at 1 p.m. So 11:30 a.m. to 1 p.m. is 1.5 hour. Oh, now I understand if I draw the line. Yes, you have to draw the line. Always draw the line. Okay, somebody asked why 3.5 kilometers? There's no 3.5 kilometers, 3.5 hours here. 3.5 hours. Right? How 3.5 hours? Anyone can tell him why 3.5 hours? Because from 8 a.m. right to 11:30 is 3.5 hours. Okay? All right, let's move on to the next question. All of you okay? All Alright, well done. Okay, don't worry if you don't understand, you cannot catch. Okay, later when I upload the video, you can review the questions again. Alright, now this time around, strategy number 7, moving towards each other from opposite direction but start at different time. So one start first and then followed by the other object. Okay, now let's take a look here. A bus travel at a uniform speed from town A to town B. It passed a car which was traveling at a speed of 80 kilometers an hour in the opposite direction. Okay, a bus traveled at uniform speed from A to B, right? A to B. The bus travels, It passes a car which was traveling at 60 kilometers in the opposite direction. So the car was traveling in the opposite direction. Okay, so they meet at some point. 4 hours after they pass each other, the bus reached town B, right? The bus reached town B, and the car was 30 kilometers away from A. So the car was 30 kilometers from here, and the bus reached town, right? And the bus took 9 hours for the entire journey. Find the distance between the two towns. Okay, now let me draw for you the distance speed timeline, that you can visualize the problem. Okay, so you can see here town A and town B, right? So the bus is moving in this direction. So you can see this is the bus, the way the bus moves, and the car is moving in this direction. Bus move this direction, the car move this direction. Okay, so the bus was A to B. It was traveling at a speed of 80 kilometers in opposite direction. 4 hours after they pass each other. So this is the point. This is the point where they pass each other. This is the point where they pass each other. 4 hours after they pass each other, the bus reached town B. Okay, the bus reached town B, and the car, in 4 hours, the car was here, which is 30 kilometers away from town A. Okay, so if the bus took 9 hours for the entire journey, right? Find the distance between the two towns. Okay, so this is the distance timeline. It's very important. All right, so I give you some time to work out. Okay, please work out, no problem. Try, I want everyone to try. Okay. Okay, some you get 670, some 630. Okay, importantly, everybody must try. Uniform speed means the speed are the same. Right, some of you get 630. Haris, please try. Don't say I don't know. You must try. Okay, I've already given you a clue. I've drawn for you the timeline. Okay, some of you get 720. Okay. Now let's work out together. Let's work out together. Okay. Now, first step, find the distance traveled by the car. Now, what's the formula for distance? Speed times time, right? So since we know the speed of the car is 80 kilometers per hour, okay, and the car took 4 hours to travel, right, from here to here, right? So the distance is 80 kilometers per hour multiplied by 4, you get 320, right? So from here to here is 320, okay, and from here to here is 30, right? So 320 times plus 30, you get 350. All of you got that? Do you all know why multiply by 4? And where is 320? This part here, this is 320. Right? How do you know 320? Because the speed of the car is 80 kilometers an hour, and the time taken from here to here is 4 hours. Alright, so speed times time, you get 320, right? So this is the distance. And since they tell you in the question that the car was 30 kilometers away from town A, so you add up, right? 30 kilometers plus 320. So from here to here was 350 kilometers, meaning the bus traveled, okay, from town A to the point where they meet, the bus had traveled 350 kilometers. Okay. Now, since do we know the distance is 350 kilometers, the speed of the bus, now speed is distance divided by time, right? So distance is 350 kilometers and the time is 5 hours. Now, how do you get 5 hours from here? Right, because we know that the bus took 9 hours, right, to travel to town B, and the time taken from here to here is 4 hours. So 9 minus 4 is 5 hours. Okay, so 350 kilometers divided by 5 hours, you get 70 kilometers per hour. We know that the speed of the bus is 70 kilometers per hour, and distance is speed times time. Right? Since we know that the bus took 9 hours to travel from A to B, and the speed is 70 kilometers per hour, so 70 multiplied by 9, you get 630 kilometers. Okay. I only got it correct. I only got 630. Rest of you just follow the answer. Everybody put 670, all we put 670. Yes, the bus took 6 hours to reach town B. Okay, why 6 hours? Why 9 hours? Sorry, 9 hours. They tell you in the question, right? The bus took 9 hours to travel the entire journey. Okay, so since from the point where they meet the end is 4 hours. Okay, so if you work backwards, okay, from here to here, the bus took 5 hours. All right, so 350 divided by 5, you get 70. Okay, all of you okay? All of you understand? Huh? I think most of you get 670. Just someone just follow everybody. Who got 630? Frankly, who work out and get 630 kilometers? You got 720. Okay, you understand now? Now you understand, huh? Okay, very good. Well done. Got 670. Yeah. Okay, so the answer is 630. Okay, let's move on to the last question. Everyone ready? Irin, okay, very good. Well done. I'm happy to hear that you understand. Huh? All right, last question. This was a past PSLE question. So in this question, there are two objects or two persons which is moving away from each other from the same point. Okay, they start from the same point and then moving away from each other. Okay, now let's analyze the question. Let's analyze the question. All right, Alice and Huda started jogging from the same point on a 5 kilometer track. So the entire track was 5 kilometers. Okay, they started at the same time but in opposite direction. Okay, in opposite direction. Alice jogged past Huda after 2 kilometers. So Alice jogged here, and then Huda jogged in opposite direction. And after 2 kilometers, now can you tell me from the clue given to you, who jogged faster, Alice or Huda? Anyone can tell me? Some say Huda, some say Alice. Who jogged faster? Huda, Alice. Okay, maybe. Who wants to explain? Okay, Faris, you say Alice, right? Okay, why? Why do you think Alice jogged faster? Jovan, why do you say Alice jogged faster? We have Huda here, right? Huda, where are you? Are you around? Huda, can you tell us who jogged faster? Distance is shorter. Can you elaborate? Huda, you're here. Good. So Huda, you are saying that Huda is faster. Well done. Okay. All right. Now, okay, the answer is Huda. Okay, the answer is Huda. Okay, why? Why? Why the answer is Huda? Very simple. Read the question very carefully. Yeah. Okay, Alice jogged past Huda after 2 kilometers. So that means, right, both of them start at the same time, right? They start at the same time, and after 2 kilometers, now 2 kilometers is here, right? Cover here, and this is the point where Alice and Huda meet, right? So these 2 kilometers, and since this is a 5 kilometers trek, from this point to this point is 3 kilometers. So you can see that Huda has covered 3 kilometers, right? But Alice has covered only 2 kilometers, right? So you can see obviously from here, you know that Huda runs faster or jog faster. Okay, Huda? Well done, Huda. You are correct. Okay. Now, let's move on. Okay, I give all of you 3 minutes to work out the answer. Okay, so Alice took 40 minutes to complete one round. Was Huda's jogging speed in meters per minute? Okay, try. Sophie got the first answer. Don't copy everybody. Since just now you can see the answer. Everyone copy everybody and everyone got it wrong. Okay, so please try on your own. The answer must be in meters per minute, not kilometers per hour. Please take note. That's 75 meters per hour. Okay, please take note. It must be in meters per minute. Meters per minute. Okay, so you can see that Alice took 40 minutes to complete one round, right? So you know the time taken for Alice is, okay, 40 minutes. Okay, the time taken, what about the distance, right? So we know distance and we know time, and we can find the speed. Okay, 24 meters per minute. Okay, let's work out together. All right, so the speed for Alice is the speed for Alice, to get the speed distance divided by time, right? So distance is 5,000 meters. 5 kilometers is 5,000 meters divided by time taken. Time taken is 40 minutes. Okay, so the speed for Alice we know is 125 meters per minute. Okay, so at 2,000 meters, okay, the time taken by Alice is 2,000 divided by 125, right? So time is distance divided by speed. So since the distance is 2,000 and the speed is 125, okay, so Alice would have taken 16 minutes to jog from here to here, right? Alice took 16 minutes. So in 16 minutes, Huda would have traveled 3 kilometers, right? How do we know 3 kilometers? Because they meet at this point. Okay, so since Huda traveled 3 kilometers, okay, and we know that they met after 60 minutes, so 3,000 divided by 16, you get 187.5 meters per minute. Okay, understand? So you can see it's not that easy, Okay, it's not that easy. Okay, very important. Always draw your distance speed timeline. Read very carefully the question. Okay, and a very important clue is that if you must always know the formula. If they give you two of the variables, distance and speed, straight away you know that you need to calculate the time. Likewise, if they give you the time, straight away you know that you can calculate the distance. Okay, Daniel, you still don't understand? Which part you don't understand? Okay, you can read carefully here. So I repeat, just one more time. First, you find the speed for Alice, right? How to find the speed for Alice? So speed is distance divided by time. So the distance is Alice jogged for 5 kilometers, which is the same as 5,000 divided by 40, right? Since he took 40 minutes to complete one round, so 125 meters per minute. Okay, so at 200 meters, so we know that Alice jogged from here to here, right? At the speed of 125 meters per minute. At 2000 meters, Alice took 16 minutes. Okay, Alice took 16 minutes, and at 60 minutes, she also met Huda, right? She jogged past Huda. Both of them jogged past Huda. So Huda took 16 minutes to jog from this point to this point, which is 3 kilometers, right? 3 kilometers. So in 60 minutes, Huda would have jogged 3 kilometers, and Huda's speed will be distance divided by time. Since the distance is 3,000 meters, right? From here to here is 3,000 meters, and the time taken 60 minutes. So 3,000 by 16 is 187.5 meters per minute. Okay, Faris, understand? Okay, nah? All right. We are done. Okay, question and answer. Any questions? Okay, question 7. Somebody asked, teacher, if they ask what time will the bus and the car meet each other, how do you answer? Okay, so this is the point where the bus and the car meet, right? At what time? Okay, we are not able to tell the time because there's no start time and the ending time given. They are given in terms of the duration, right? But exact time, the when they start from town A and from town B, it was not given, so it's not possible to calculate the time. Okay, when they meet, right? So it's just in terms of duration. Okay, so we ask why 80 times 4. Okay, 80 is, this is to find the distance, right? So distance is times time. So we know that the car the speed of the car is 80 kilometers per hour. So the car took 4 hours to travel from here to here, right? From here to here, the car took 4 hours. So that's why 80 times 4, you get 320. Okay. All right. Okay, everyone. So thank you very much. Okay. Okay. I wish all of you I shall right now. Okay. We will continue in the